Welcome to this tutorial on how to make a sound amplifier. Now I'm assuming you guys already built the piano in tutorial 8. Noticed it's not that loud and you want to add some pop. Maybe to make it loud enough to annoy the neighbors and be heard. Now in order to do that, you're going to need two things. One, something that generates this extra current and power that you need, a 9-volt battery. And two, something that amplifies the signal out of the Arduino, which is a transistor that can take all the way up to 1 amp of current. If you put your speaker in a circuit with those two, just like this, so this would be the plus of the battery, that would be the plus of the speaker, minus of the speaker, in your transistor collector, base, emitter, all you would need to do is connect the base to your output pin. Maybe 11. So this pin would go on, off, on, off, on, off. The current going through it would be multiplied all the way up to possibly the max of the 9-volt battery. So you'd go from like 50 milliamps to 500-600, something like that. And this speaker would be 10 times louder. So there goes the theory. Let's build a thing.
Alright, so as you've seen already in the piano circuit, the sound generated by this Arduino through the speaker is not that loud. Now we're going to boost that using a 9-volt battery. To do that, we're going to need to use a transistor that can take, up to 1 amp of current. So this is a bigger one than we've previously used. It's the BD135, and its configuration is different from most transistors. So instead of eat big cookie, emitter base collector, this is eat cookie big, emitter collector base. So our signal from the Arduino is going to go into this pin, our ground is going to go into there, and our speaker will connect into the middle pin through the power. So let's get started. First of all, power supply. As usual, plus into the red rail, minus into the blue rail, and then we can get our transistor in. You can go in somewhere in the middle, one pin sticking out. Now there's some obvious things we can do straight away. We're going to generate a signal out of pin 11. And it's going to go into the base. Now actually, we'd be better off putting the volume controls here. It's the best place to put it. So this tiny signal will get basically increased or decreased, and then our volume is going to depend on how we turn this variable resistor. And we just need to get our speaker in. Now the red line of the speaker is going to go into the power, and you can imagine that this red line continues, so the plus of the speaker ends up here, and that is our collector. The speaker goes in there, our emitter goes into the earth, so that's there, he goes into the earth, and generally speaking we connect the earth also. If you have two devices, we connect the earth, so this goes into the GND. Nice. Well, I think it's ready to go. All we need to do is put in a simple program.
Alright, let's test this circuit. This is as simple as audio generation through an Arduino gets. Pin 11, the one with the yellow cable, is our output. It goes on for 1000 microseconds, which is effectively 1 millisecond, and off for 1000 microseconds. So that will be a 500 hertz tone. Let's see.
There we go. And get ready. Ooh. Yep, that can get pretty loud, and I think that the 10K resistor is a good one to use here. Now, while we got the circuit, let's try to make some fun sounds.
The simple one I can think of is a bit of an imitation of the Doppler effect. It's like the Formula 1 passing a viewer. It sounds like... So all it is sound being compressed coming forward, so having a really high frequency at the start and a low frequency later on. So that's what we're going to try to replicate. To do that, we're going to get a loop inside a loop. So we're going to write a for loop here, and it's going to have a number, I, and so that's going to be int I equals 1. So we start at 1, and we go until, say, 2000. So 2000 microseconds, yeah, that's pretty good. These are punctuated by semicolons, and we increase 1 by 1. So I equals I plus 1. Okay, so that open the loop there and close it there. So if we run this code, nothing unusual is going to happen because the delay is still 1000 here. But we can make this delay I. And I is going to start out at 1 and then increase all the way until it gets up to 2000. So it'll be like a huge range of frequency. So if we put I there, we should hear something interesting.
Whoa! There we go. That's a simulated Doppler effect. And you can make it happen 10 times faster by changing, say, instead of increasing it by 1, we can increase it by 10. And I think it's going to sound something like galactic gunfire. Alright, this will do for today. Thanks for watching, guys. Guys, just letting you know that every single one of these tutorials comes with a downloadable PDF manual and the finished program. The PDF manual usually contains more information about the program and step-by-step instructions that are illustrated on how to build a circuit. And the downloadable program will be sure to save you some time. So, hop on over to robotics.com.au.